So thank you guys, thank all of you guys for the questions. Just so you know, this was a preview of the Career Opportunities workshop this afternoon. Ernest is also leading that workshop. It starts at 1. He has several member panelists. Let me get you their names real fast. He's got Wendy Erickson from Women in Drones. He's got Jordan Kruger from the University of North Dakota. He's got Divya Budthal from Zipline, and I'm not sure if Matt's going to be able to make it or not, but there'll be plenty to talk about there. It's an hour-long presentation, and then you can do questions and answers then as well. So that'll be at 1 o'clock. Now I would like to talk to you a little bit about the curriculum in drones. So hopefully Matt can stay on and answer some questions for you. But I want to talk about the curriculum at the moment. Later, this is a preview for a 2 o'clock presentation. So if you want to know more about curriculum in drones, you can attend the 2 o'clock breakout session. This one will be in the webinar. So you just come back to this webinar at 2 p.m. and you will be able to attend this workshop. So this is specifically on drone curriculum in classrooms. So we haven't really talked about what it is you need to do to prepare to do drones in the classroom. And there's a lot of things you need to consider, and that's why we have this conference. And these are the questions you need to consider when you decide that you're going to go ahead and do a drone program. There's a lot of things to consider. One is permissions. Do you have the right to do this? Can you do this? Is it legal to have drones in your classroom? And that's a really good question. And that's what the breakout session this afternoon is going to be on. It's on safety and regulations. Desi Eckstein is going to be running that panel at 2 o'clock. So just as an aside, 4 years ago when I started all this out, I got a phone call from FAA saying, what do you think you're doing as a teacher? And I was actually running some drone camps, and I was going, I'm just running drone camps. And the FAA officer said, well, you can't make money with drones and teaching kids how to do drones unless you have a Part 107 certification. I was going, really? Well, what do you want me to do with this camp? And he was going, well, we could shut it down. And I was going, no, don't do that. But what has happened since then, and regulations are changing very, very rapidly, is that teachers are a special case when it comes to drones. You do not have to, so teachers would like to do drones in the classroom, and that's cool, and that's okay with the FAA, but you are actually doing it on your time and you're being paid to do it. So you're sort of breaking the rules because you're not supposed to get paid and not have your Part 107 certification. Well, they clarified that, and teachers are fine teaching without Part 107. But if you are going to go outside, I highly recommend you get a Part 107 certification from the FAA. It's really not that hard to get. The test is like a driver's test, you know how the inane questions, but if you're going to be going outside quite a bit with drones, you might want to consider doing that if you're going to be teaching with drones. Permissions also came into an issue when I started doing drones here at SMU, and somehow the lawyers at SMU got a hold of it and said, well, that sounds dangerous. You shouldn't do that. And I said, well, I can, and I know the regulations, and these are the regulations. Do you mind if I do that? And they're going, oh, those are the regulations. That's fine. So as long as they knew that I was on the side of the law and I was following the law, then they were okay with it. But it's important for you to understand that as well. Then you have to decide whether you're going to use the drones indoors or outdoors. So indoors means you're going to have a pretty small platform and you're going to be able to fly it around in your classroom, and that's fine. There's sometimes problems with doing the small ones because they don't have as many capabilities as the large ones. And they generally can't do authentic things like go deliver packages or something along those lines. But the indoor makes sense, but there are safety issues with indoor drones. There's also questions about how many drones do you have per student, or how many students per drone you need. So you have to consider that. And then if you want to go outdoors, you probably want to consider a Part 107, and you really need to understand your airspace. And once again, that comes from understanding, doing the Part 107 regulations. But if you're near an airport, and what near an airport means is kind of an FAA definition, you may not be able to fly at all. If you've got a Part 107, you're going to be able to fly in a lot more restricted areas than you might otherwise. And there's some really cool apps and other types of things you can look at for figuring that out. So all of that information is going to be available to you through the workshop at 2 o'clock on regulations and safety. Then you have to consider the platform you're going to use. So Ron Pointer is going to be doing a presentation right after I finish, talking about the drone platforms, the different types of drone platforms. They all have different capabilities. They all have different dangers. They all have different controllers, and they're just different in what they can accomplish that you can use and accomplish with them in the classroom. So you need to figure that out. We have workshops on that. Ron is going to be doing a preview this morning, and then he will have a full breakout session this afternoon, I think at 2 o'clock. Then you need to consider the budget. Drones are becoming much less expensive than they have been in the past. You can get a drone for $29. It's not a very capable drone, but you can get drones for your classroom for much less than a textbook might be. And it used to be you could buy a drone and learn how to fly with a drone, a little baby drone, that would be cheaper than buying simulation software. But I believe the simulation software is now, there's a lot of simulation software that's actually free. So that may be changing rapidly. So you need to consider the budget. There's great ways to get drones donated to you. To figure out the budget, you need to figure out how many students per drone. So all of those things you need to work through. We have workshops today to help you work through those things. What will you control with the drones? What grade level will you be teaching with the drones? So it's very different what grade level you're going to be teaching as to what type of drone you want and what the capabilities are on the drones, what sensors are on the drones, etc. And then lastly, you need to consider what academic standards do you want to address. Most of those last things are going to be addressed in the curriculum workshop, but it will also be addressed in the teacher workshop. So if you have any questions about how are you going to do this in the classroom, the teacher workshop at 3 o'clock should help you there. Ask as many questions as you want for the teachers. These are very experienced teachers who can tell you all about how to use them in the elementary classroom, the middle school classroom, or the high school classroom. So there's a lot you can do there. So when you do drones in the classroom, being at a university, a research university, I highly recommend you do or you follow good teaching practices. So I highly recommend you do a project-based learning experience. Some high schools are going to capstone courses. Capstone courses are wonderful for any type of a competition. They're a wonderful way to work on very complicated projects as a team. Project-based learning is experiential and is considered very meaningful teaching. Highly recommend you consider that. If you are going to do project-based learning, choose an authentic theme or an authentic problem or an authentic project that you want to do. So PBL can be project-based learning, problem-based learning, product-based learning, however you want to consider PBL, but make sure it's authentic. And that's one of the reasons why we have Ernest here and the industry experts to explain where is the industry going? Where can you use drones? How do you use drones in industry, and how would your students, what kinds of careers would they follow in going into drones? So there's lots of possible authentic themes that you could follow. I recommend you look for those. You can find them from industry and talking with industry experts. Most of the curriculum in drones is design-based. So design-based is a little different than regular teaching. Design-based means that you've got an iteration of your product. You're going to develop plans. You'll probably go through some sort of a design review with some outside experts, possibly experts in your community, parents of your students who might come in and just give them some pointers. There would be a presentation of your design, and then the parents and the engineers would provide a review of the thinking that the students are doing. That makes it authentic again, and it also makes it a richer experience. Actually, it makes it a very rich experience for your volunteers as well. They much prefer to be involved in the teaching, or volunteers that I've talked to in the past prefer to be involved in the teaching rather than just coming for a career day or to do some other thing in the school that's not as connected to the students. And then once again, still look for a theme in industry, and that will benefit you and benefit your students and make it very relevant to your students. So where do you start in thinking about curriculum? So this is where we get to the real curriculum part and the real curriculum discussion. Well, you should think about the different parts of a drone. And once you start considering the different parts of the drone, it becomes fairly clear where they fit into the curriculum. For example, you've got a remote radio controller. Well, that's clearly physics. There's a whole lot of radio wave technology going on there. There's a lot you can discuss with regards to physics and waves and the radiant spectrum when it comes to the remote radio control. Batteries, there's a lot of chemistry there. If you look at batteries, there's fast discharge batteries, and then there's the slow discharge batteries. And there's a lot of different chemistry that goes into the different types of batteries that are available for drones. That's a fun thing to get into if you want to consider chemistry. And then the whole idea of energy. Should you use batteries? Should the drones be electric? Wouldn't it be better if they were motorized or they have engines on each of the props? Wouldn't that be better? Well, there's chemistry again. How does a combustion engine work? What is the controlled reaction that is happening? What are the inputs? What are the outputs? There's a lot of chemistry that goes into that. Is a engine better than a motor, or is a motor better than an engine? That's a wonderful question to ask students. They can learn a lot from that. Propellers. Propellers on a drone, they have to be spinning in different directions. Why? That is the exact reason why there is a little teeny propeller on the back of helicopters. There is, if you've got a rotor moving around in circles, then that's going to tend to make your entire airframe spin around in circles as well. So you need to do something to compensate for that. So I really enjoy using gyroscopes in the classroom. You can still find those little teeny gyroscopes, spin them up, and see how they work and what they can do for you. So using gyroscopes, propellers work, is a wonderful discussion there. Propellers can be large propellers or small propellers. What's the difference? It has a lot to do with lift. You can bring that into your classroom for aerodynamics or a number of different things. The airframe is important. If you start looking at the airframe, you start looking at things like center of gravity, momentum, the materials that go into your airframe. What does it need to be made out of? Once again, that's chemistry. Then you've got all of the electronics in your drones. You've got a flight controller. You've got the electronics that goes through the electronic speed controllers that control the speed of each of the motors and each of the propellers around the drone that allow it to steer. Then there's lots and lots of sensors, and you can talk about sensors all day long. There's infrared sensors, there's cameras. Well, how do cameras work? What are the lenses on the cameras like? So lots of physics that you can talk about with regards to sensors. Lots of the radiant spectrum that you can consider when talking about sensors. And then the barometer that's in every drone these days. And the gyroscopes that are in the drones. So there's lots of sensors, even in the smallest of drones. And they also have to sense the radio transmissions coming from them. Then there's motors. Motors are wonderful things to play with. If you turn a motor with your finger, they actually create electricity. So you can show how motors work, and then electricity is produced just by turning the motor rather than using electricity to turn the motor. So that's a wonderful thing to do. And then there's lastly programming, lots and lots of programming. There is an entire session this afternoon at 3 o'clock that Marissa Vickery is going to be leading on programming. You can do programming in the elementary school with block programming. Then you could use Python, and then you can go all the way up to C if you so choose. So there's lots of things that you can teach with drones. Once again, there's science. In physics, there's Newton's forces, there's electronics, there's motors, there's batteries, sensors, cameras, radio transmissions. All of that is in physics and science. It's also chemistry. Lots and lots of science available through teaching of drones. There's a lot to be taught in computer science and computational thinking with regards to drones. Once again, that's the programming session. There's a lot of mathematics, the geometry, the algebra, lots of budgeting if you get into that. There's the STEM processes. So every standard is the content standards, what you need to know, and then there's the process standards, how you need to do it. So in science, there is the scientific method you should teach. In engineering, there's the design process that you should teach. In mathematics, there's the problem solving process that you should try to teach, logical thinking, etc. And when you teach about drones, consider the job skills that are important. The Secretary's Commission on Necessary Skills for the 21st Century mentioned and has focused on a number of different things in education. Education has kind of distilled them down to the 4 C's. So it's important to teach kids, and industry likes it, and it's been proven over and over again that industry would love for kids to come out of high school or grade school with being able to communicate well, to think critically, to be creative, and to collaborate. Those are the 4 C's. Those are not tested in schools, but they should be part of any kind of a drone curriculum because they're so important to industry. And it's been proven over and over again that those are desired in industry possibly more than content knowledge. So those are the things you can teach in curriculum. And then you also, when you put together, you learn to use, you start using drones in the classroom, you learn very quickly that organization of your classroom is very, very important. How do you keep all the batteries charged? You've got 20 drones, you've got 20 batteries. How do you keep them all charged? Because if you've got a bunch of small drones, they're going to last for 20 minutes, and then you still have 40 minutes left in your period. How do you manage that? How do you manage the batteries? How do you recharge them so that they'll be ready for the next class? How do you make sure that a drone that is used in this class is going to be able to be used in the drone as a drone in the next class? So that has to do with spare parts and other types of things like that. You also need to deal with this binding issue. This is an unusual thing that drones have, that they are supposed to connect via radio to the drone. Your controller needs to connect via radio to your drone. Well, if you've got 15 drones sitting in your room and you've got a controller you're trying to bind to a drone, it doesn't know which one to bind to, and you may end up flying a drone that you were not intending to fly. So all of those things are issues that you should consider. All of those things you can learn about in the curriculum and the teacher breakout rooms later this afternoon. And then what types of spare parts do you need? Those are all important questions. So does anybody have specific questions regarding curriculum and where you can learn more about the curriculum this afternoon? Did I get any questions that? Any questions?
There are a few questions here. One of the questions is, do you have any comments on privacy and the use of drones?
You're not supposed to fly, if you are outside, you are not supposed to fly any drones over any human being yet. So you cannot fly a drone into somebody's yard. You cannot fly a drone into and spy on anybody. And once again, that is a regulation issue. Highly recommend you take a look at the regulation workshop later this afternoon. Okay, I'm going to move right into the next session, and if I find any questions that I can answer specifically about curriculum, I'll go ahead and do that. So I'm also want to talk about drone competitions. So there is a special breakout room for breakout session for competitions. That is going to be at 3 o'clock this afternoon, and it's going to feature Tad Dowse from Drones in Schools, myself, and Philip Teschler. So there's a lot of different drone competitions out there. There's a lot at the upper elementary and middle school. There are a very few at the university level, and there are very few at the high school competition level either. And the way you can identify different types of drone competitions are along a spectrum. So there's a lot of different spectrums to follow. There's the spectrum of elementary to university. There's the spectrum of an individual competition to a team competition. You can, there's competitions that focus on flying. There's other competitions that focus on designing. And there's competitions that use inexpensive drones. And then there are competitions that use very expensive drones. There are small drone competitions and there are large drone competitions. And the difference between these is primarily the skills. On the left-hand side, I think that's your left-hand side, the basic skills, the elementary, the individual type of competition, the flying competitions, the inexpensive competitions, and the small competitions generally are fairly basic. They're done by an individual. You can do this by yourself. Students can do this on their own. And there's lots and lots of these different competitions. They primarily focus on flying. So you learn how to use your controllers. You learn how to use your controllers to turn, to flip, to go up in elevation, to drop in elevation. They're primarily a skill-based type competition. On the other end is the technical skills. And if you've got a big technical skills, you generally need a team to make that happen. It's not an individual competition anymore. You need specialists. You need somebody to specialize in electronics. You need somebody to specialize in the drone itself, the drone body. You need somebody to specialize in the mechanics. You need somebody to specialize in the sensors. So you need a team to work on the more highly technical competitions. And the technical competitions generally have designed drones. So you start with some sort of a stock drone, and then you add things to the drone. And once you start adding things to the drone, things get very messy and complicated because the drone no longer knows how to stabilize itself. So you have to learn how to mess with the software so it can stabilize itself properly. Generally, these drones are more expensive, and they're generally larger and generally are outside. And you probably want to learn some heavy-duty software to do it. And once again, a software person would probably be one of the members of the team. So this is the spectrum of competitions that we will be presenting this afternoon. So drone racing is wildly popular. There's lots and lots of competitions out there now. It's primarily an individual sport. It is done through a teleoperation. So if you don't want to do autonomous drones, then it's primarily a teleoperation, and it primarily focuses on flying skills. Drone racing competitions generally use these types of drones. This is a Mambo drone that comes from Parrot. That's a French company. It uses, you can put your cell phone into those goggles if you like to see what your drone is seeing. If you click on the camera there, and then you control it, you can either control it with your phone or you can use an extra controller to use it. These are really fun, very capable and programmable, and they're smaller ones. Then these are the Telos. This is from DJI, very capable drones, and they have a camera as well. And then this is more of a racing drone. It has a camera out front, but it also has a big GPS tower on it. So this is meant for going outside. This is a PCS Adventures drone. So it's made for racing. It's a little different. Multi-GPS drone competition. You're going to hear more about that from Tad this afternoon if you go to the competition breakout room. And then there are the hybrid drone racing competitions. And this is drones in schools. And once again, this is Tad, runs drones in schools. And there is a design component to this race. So there is 3D printing involved in it. And there is some interesting design things that go along with drones in schools, but it is a small racing quadcopter indoor competition. And they use these little drones, but I think they take them apart and then you create or you 3D print a design for your actual drone. And they've got some drone prints that you can use at drones in schools. And this is another drone that you can take apart and build into your new racing drone for drones in schools. So there is a design component. Then at the university level, you can learn about this SUAS. This is pronounced SUAS, a student competition for at the university level. Some high schools have gotten into this, but it is primarily a college competition. And in the college competition, you can see the drones are much bigger. And then this is the drone in flight. And if you take a look at it, you can see a little rover underneath it. So not only do you have a flying drone, but you also have a ground-based drone in this particular competition from SUAS. And that's an AUVSI competition. This is at the university level, very difficult, requires a team of specialists. Really neat stuff though. This is another drone that you can use in the exact same competition. So you saw a quadcopter, a multi-rotor competitor. This is a fixed wing competitor. And this is really, really cool. It has a stealth look to it, but in either case, you can compete with a fixed wing or a rotocopter. This one actually, well, I think it's a fixed wing, but it looks like it's got rotors as well. In any case, you can compete in this competition with a fixed wing if you so choose. So this is the competition field. This is a small airfield. So this is a very big jump and a very different thing to do and to get involved with. This is more for an expert group, a more advanced group, but it is certainly something one might consider getting into. The high school competition is one of the things that this group, our group, the Go Drones at the moment called Go Drone Group, is trying to create something in between. So if you want to go to the competition breakout group, you will learn about the elementary competitions, university competitions, and the high school technical competitions. So that's what that is. Let me see if there's some questions that I can answer with regards to this. So someone was saying that the Part 107 is a lot to ask for teachers. That may be true. And if you want, you probably want to start small and with small drones, and then you don't have to have your Part 107. But once you start going outside, then you might want to consider getting your